Hello National 5, it's Mr. Neil here. In this video we are going to be covering the computer structure part of the computer systems unit. As part of computer structure, we need to know about the computer processor and the different parts within it. We need to know about memory locations and we need to know about buses. So by the end of this video, you'll be able to describe the purpose of the processor. You'll be able to describe the purpose of the control unit, the arithmetic logic unit and registers. You'll be able to describe the purpose of main memory. You'll be able to identify and describe the control, address and data buses, and you'll have a rough idea and be able to describe how buses are used to read and write information to and from memory. So let's dive straight in and have a look at this. So this here is a simplified version of the von Neumann architecture, and this is a design that could represent most computers that exist in the world. We start with the input, and this is information going into our computer system. So for this presentation, my mouse is inputting a position that is then moving my mouse pointer. The computer then processes that information and an output comes out of that. So I move the mouse on my desk, and then the output is that on the screen I can see the mouse cursor moving. From the processor, we also have backing storage. So this is my computer hard drive, or I've got a CD drive, or I've maybe got a USB flash drive plugged in. And then we've got main memory, which I use all the time. And the main form of main memory is random access memory, or RAM. So I've got this PowerPoint here loaded up on my computer, which means it is currently sitting in RAM. So if we start looking at the processor is the brain of the computer, and it deals with all the instructions that take place in the computer. If there's no processor within the computer won't work. Even the simplest kind of computer will have a processor. Computers can carry out millions of instructions very quickly, but traditionally a processor can only handle one instruction at a time. It just handles them very quickly. Two things that's good to know about processor is the terms clock speed and multi-core. So clock speed is the speed at which a processor carries out instructions, and it's measured in hertz. So those of you that have done physics will have heard of this term. Hertz is the measure of frequency, which is the measure of how often something happens per second. So in computing, the clock speed is measured in hertz, and that is the number of instructions that the processor can process per second. Nowadays, most processors are measured in gigahertz. So for example, my computer here is a 3.1 gigahertz processor. Traditionally, a computer would only have one core, and that's what I was saying earlier by the computer can only manage with one thing at a time. However, modern technology means that a computer can have multiple cores in its processor, which means it can actually do 4 things at once, so it's faster. So if you've got 4 cores to your processor, you've got a quad-core processor. Modern computers, you might get a hexa-core processor, which means you've got 8 cores to it. So now let's look inside the processor at the 3 main components within the processor. We've got the control unit, the arithmetic logic unit, and the registers. The control unit controls the order of executions and the timing of instructions. So it sees the instructions that need to be executed and decides how it's going to execute those. The arithmetic logic unit, or the ALU, performs any calculations and carries out logical decisions. So that could be as simple as adding 2 numbers together, or it could mean determining the output from an if statement. The last component is the registers. These are a temporary data store within the processor. So they store the information of the current or next instruction. So for example, if the arithmetic logic unit added 2 numbers together, the answer to that calculation could be stored in the register. Buses link the processor and main memory together, and they are used to transfer data and send signals between them. The 3 buses are the control bus, data bus, and the address bus. So like the control unit, the control bus carries the signals that controls the action of the computer. So it carries a signal telling main memory whether it's expecting new information or whether information will be read from it. The address bus carries the address for a memory location that has to be read from or written to. So this is telling main memory you need to look at location 3 or location 2 for a piece of information, or the piece of information that's going to come is going in there. So every location within memory has a unique address. The address bus is unidirectional. Information only goes from the processor to main memory. The last bus is the data bus, and the data bus carries the data that is to be written to or read from main memory. So this means information can go from the processor to main memory and then from main memory to the processor. So it is a bi-directional bus. Let's have a look at how the buses work together. We're going to start off by looking at how we read information from main memory. So you can see there in location 2 I have got a user and I want that user to be read into the processor. So the address bus is loaded up with the location, it's in location 2, and the control bus is loaded up with a read command. This information is then passed over to main memory and the data at location 2 is loaded onto the data bus and then transferred over to the processor. Let's now assume that we want to write some information to main memory. So this time, the address bus is loaded up with the location that we're going to, in this case location 3. The control bus is loaded up with the write command, and the data that we're transferring into main memory is loaded onto the data bus. This information is then transferred over to main memory, and the password goes into the specified storage location. So in this video we have looked at the processor, we've looked at memory, and we've looked at buses. And this means that you should be able to describe the purpose of the processor, the control unit, arithmetic logic unit, and registers. You should be able to describe the purpose of main memory, focusing in on the address of each location. You should be able to identify and describe the control address and data bus, and you should be able to describe how the buses are used in read-write commands.